The last big piece we are going to address is causality. We're going to talk about it in two ways. First, we consider the 4 criteria of causality. Before we go any further, I want to emphasize to you that we never, ever, ever, ever prove causality. We present evidence that supports or refutes a claim of causality, but that's as far as we can go. Once we have done our bivariate and multivariate regression, we have some of the evidence that we need. Empirical association between the two variables we are looking at. The second criterion is having a plausible theory. The formal definition of a theory is a process that creates the connection between the independent variable and the dependent variable. All we're trying to get at is how and why the relationship occurs. A third criterion is that the independent variable is set before we observe the dependent variable. This is called temporal priority. It's a mouthful, but the concept is not actually all that hard. The fourth criterion is non-spuriousness, and this is when a relationship between two variables is not due to variation in a third variable. To put it another way, the relationship between the two variables is unchanged when we control for other variables. Occasionally you will find this in your analysis, but more often you will see at least a modest change. We will talk about the nuances, but the bottom line is that your safest bet is to acknowledge that some spuriousness is inevitable, where you find evidence of it in your model or not. All of that, those 4 criteria of causality, are the first way that we talk about causality. The second way is experimental design. Rather than give you a definition of experimental design, I'm going to give you an example. Suppose we want to investigate whether school breakfast improves students' academic performance. We assign students to each of 2 groups. They are about the same age, similar intelligence, similar mental capacity, and so on. No individual child was more likely to be assigned to one group or the other. Then one group receives breakfast at school, the other does not. We observe performance of students in the experimental group who received school breakfast, as well as the performance of students in the control group who did not receive school breakfast in an exam. Exam results show that students who received breakfast performed better than those students who did not. Because the students in the 2 groups were roughly the same, except that some of them had school breakfast, we can attribute the difference to the school breakfast. When we can do a full experimental design, the results are considered to be pretty sound. Unfortunately, we rarely have enough control over the situation to be able to execute a full experimental design. Still, sometimes we can get fairly close, and fairly close can be pretty good.